because certain things have to be understood thoroughly, and there is hardly any provision for us to appreciate it so deeply the way it has been taught to us, and perhaps it is being taught to us. See, now there is a certain trend that people try to choose those careers which can be highly lucrative rather than whether it is really enjoyable in the long run or not. This kind of a thought doesn't come. You should not just simply get carried away by those careers which you feel is going to be highly lucrative. No. Okay. So these lucrative jobs, etc., can be fascinating only for a very short while. But when you try to engage your minds in doing serious academics, it can keep your interest till the end of your life. So it is extremely important that you train yourself to learn new things and enjoy in that process. So one should pursue interest, but when you pursue interest, so you just do that thing. Okay. So putting all your mind into it, whether you are sweeping or you are learning an important mathematical problem, doesn't matter. Do that. So don't worry about where this is going to lead me. So at that moment, I should just see that I engage myself fully. This is very, very important. So if we can really make them appreciate the subject matter which they are learning by providing historical inputs as to how the ideas emerged, that will shape their minds.
But moments of serendipity in a physical library where you just come across a book and you decide to go this way and not that way, and you find yourself in front of a shelf. But I founded the work of Euclid's Elements, which is really foundational. I want to read ancient mathematical texts in very old languages and try and figure out what they mean. And so the next thing you do after that is read the most beautiful Indo-European language of all, which is Sanskrit. So keep your brain thrilled. That's the question you should be asking yourself. How can I keep my brain thrilled? It's much more difficult to get a broader approach to how humans have embraced mathematical ideas and carried out mathematical ideas from a real variety of cultures of inquiry throughout history. And so really important, I think, the plug is, it's a source of national importance that we understand who our scientific predecessors are. And so approaching these topics, when you're looking them at in context and looking what motivated the original discovery, it can be incredibly powerful to the sorts of learners who are not immediately attracted, as you say, to the more analytical, algorithmic approaches.
Good morning, good evening, good afternoon to one and all, and welcome to this series of expert talks. Today is the 6th in our series, and we are extremely happy and honored to have two great mathematical historians, Clemency Montelle, who is joining us from University of Canterbury, New Zealand, and Professor K. Ramasubramanian, who is a professor at Indian Institute of Technology, Mumbai. And I cannot tell you how happy we are to have these two fantastic people. I cannot tell you how much it means to us that they both agreed to do this session on mathematics and humanities. Just to give you a brief introduction about both the professors, I will start with Professor Clemency. She did her bachelor's and master's in mathematics from University of Canterbury, and during her undergraduation, she found that she is interested in mathematics and classical studies. And when she came across the work of Euclid, which was originally in Greek language, and she thought that this is a fascinating area, and I want to combine my interests of mathematics and history. And she did her PhD in mathematics and classical studies from Brown University in United States, under the guidance of great historians of mathematics like David Pingree and Kim Plofker. After that, she has been a professor at University of Canterbury, and is involved in doing research on Indian mathematics and Indian astronomy, and reads original texts of Indian mathematical texts in Sanskrit, Greek, and also Arabic. So a truly a person, in some sense you can call her as a polymath who dwells into mathematics and in multiple areas. So welcome, Clemency.
Yeah.
And we have Professor Ramasubramanian. Uh, Telling anything about him will be like showing lamp to the sun, because his credentials, his research is astonishing to say the least. When I say Clemency is a polymath, and I think Ram Subramanian sir is he dwells into multiple areas, and he is an expert in all those areas. If you think of 3S, that is science, spirituality, and Sanskrit, he is an expert in all these three fields. He has got numerous awards from government of India. For example, he's been awarded by the president in 2008. Then in Sanskrit, Shankaracharya awarded him for his uh, uh, courses that he has done. And under his guidance, plenty of students have got an opportunity to learn under his guidance. In fact, his lecture on social media has been viewed 1.3 million times, where he talks about the calculation of pi using Indian method. So just to tell you that his roots are such that he can merge the modern and the traditional areas with ease. Uh, he has done his undergraduate degree in engineering. He did his master's in Sanskrit, and he has a PhD in theoretical physics. So you can see the wide spectrum of knowledge that he has acquired, and now he uses his knowledge in different domains and combines them in the form of research by disseminating or understanding the knowledge of Indian science and Indian astronomy. And he is currently working on a very ambitious project wherein the knowledge of Indian sciences will be preserved and will be converted into a digital form, and it will be available in a searchable form, so that it's easier for us to search for those texts. So welcome, Professor Ram Subramaniam, and we are
Okay,
excited
thank
to
you. I was wondering, Hari, I was
yes.
wondering who we were talking about.
So with that, we will open the floor to both Clemency and Ram Subramanian. Uh, so why don't you both start with talking about your journey, how you came into this field, what was your motivation, or at what point of time you started thinking about these areas?
I wish Clemency begins.
Okay, thank you very much. Yes, and thank you, Hari, for that very lovely introduction. So as you insinuated, I went to university with not really a strong idea of what I wanted to do, but I took mathematics because I'd loved it at school. Just the rigor and the structure and the certainty and the pursuit of truth really struck a chord deep within inside of me. And then I also took Greek and Latin. Now, Greek and Latin, of course, are Indo-European languages. Latin's very close to English, and they're both inflected languages, and as such are quite mathematical as well. You know, you learn paradigms, the grammar is very strict. And I continued these things completely separately for 4 years. And of course, they're in different departments on opposite sides of the campus, and I'd be running back and forth, and the lecture schedules didn't work in harmony, and the exam schedules didn't work in harmony. And people would say, Clemency, why are you doing maths and why are you doing classics, and what on earth did they have in common? And I said, well, I don't know, but I'm loving what I'm doing, so I'll keep going. And then, as you said, one day I suddenly came across in the library, which is why physical libraries are so incredibly important. I mean, we know about browsing on the internet, and that's a very important source of stumbling over things as well. But moments of serendipity in a physical library where you just come across a book and you decide to go this way and not that way, and you find yourself in front of a shelf, that I founded the work of Euclid's Elements, which is really foundational to all of mathematics, written in 300 BCE, and of course, really shaped the way in which we do mathematics today by its sort of proposition proof format. And of course, Euclid was writing in ancient Greek. And I was like, wow, this is mathematics and it's in ancient Greek. I can read this. And so if there was ever a light bulb moment in my life, then that would have had to be it. And I thought, this is exactly what I want to do. I want to read ancient mathematical texts in very old languages and try and figure out what they mean. And so the next thing you do after that is read the most beautiful Indo-European language of all, which is Sanskrit, even more complicated than Greek or Latin and more mathematical in its structure and its fixity. And the texts are diverse and the literature is amazing. And so I've really been drawn to reading ancient and early mathematical texts in Sanskrit and trying to figure out what they mean, because it's a huge, important source of scientific heritage for, as you know, a large part of the world's population. So that's how I got into history of mathematics.
That's great. Professor Ram?
Yeah. See, Clemency began by saying she was quite thrilled to know the structure of mathematics, the certainty of mathematics, the beauty of mathematics, etc. But I don't think I enjoyed any of them in my school days or even my college days. Okay, I must tell you that I started enjoying it only after reading some of these ancient texts in Sanskrit. The clarity, this is something which I must share with you, because certain things have to be understood thoroughly, and there is hardly any provision for us to appreciate it so deeply the way it has been taught to us, and perhaps it is being taught to us. My entry into this discipline was all completely by providence. I had Clemency perhaps had the opportunity to know certain things because she is a voracious reader. I know she would have read certain things, but so my family background was such that I would not have read a single novel, and even today I have not read a single novel. So I will just read some material, whatever is supposed to be read at the school level. They will give some school textbooks, and some of the teachers would not even encourage to read the entire book. They will mark certain portions and you have to just mug up, and the memory was good, so you can perform well in the examination. This is how my schooling was. Okay, so and therefore I had absolutely no clue whatsoever as to what is history, where mathematics got developed, in which civilization, what was the contribution, etc. I had no clue whatsoever. And more importantly, based on what I learned at my graduate level, I have heard of some great stalwarts like Newton, Leibniz, Gregory, and so on, Cauchy. But no chance till I completed my MSc in physics to hear about Aryabhatta, Bhaskara, Nilakantha, Madhava, whatever. Okay, Brahmagupta. No way. Because I don't even read newspaper, I did not even know about Aryabhatta satellite. Okay, so that is the background in which I was sort of brought up. But the providence decided that I had to enter into this discipline, and by the time I was about to take my MSc examination second year, there came a faculty from IIT physics department to my home, and then he said, Ram, I need your help. I said, what? So he said, there is a project which has been taken by a couple of people in the theoretical physics department of Madras University, and they are in search of somebody who knows Sanskrit and who knows science. So you have a background in Sanskrit, I know, and I have done some masters in physics, and therefore I would like you to join that group for doing research. So this was a time where I had no clue as to where I have to enter. So I had an engineering degree, as you were saying. I also had a physics degree, and some people were tempting me, leave engineering, leave physics, go to computer science. So I have done some 6 months course, and I'm able to have a fat salary. So this was in early 90s, 1991 I'm talking about. Okay, so then there was a big boom, okay, in the computer industry. So anybody who does some course in NIIT, so he will immediately be placed. Okay, whereas if you go to this regular stream, you can hardly earn 2,000 rupees. There you will immediately get some 20,000 rupees. So there was a temptation in that direction too. But somehow I was drawn into this because of the recommendation made by this person. I entered into this research work, and thereafter also there were some problems whether to continue in this or not. That I will take up later. So this is how my entry was. Okay. So because of a couple of people who took very serious interest in history of mathematics, and they were looking for somebody, and incidentally I had a double background, so therefore I was drawn into this. So this is my entry.
These are fascinating stories. In fact, the way I look at your journeys is that Clemency chose this field, and the field chose Professor Ram in some sense. So, and I can relate so much with what Professor Ram was saying, because when we grew up, it was similar, that you had no clue about what you really want to do. You were good at studies, and you could get good marks, but that inclination towards a particular field was something that happened quite late. And I think this will be a good point to ask, like, what do you think is a good age when students can start thinking about a career, whether it's a school, it's a college, or how does this actually happen? It's a very tricky question, because at what age do you actually decide a career is what it boils down to. So if you can throw some light on that, when can students decide?
It's quite a difficult question because it's such a personal one, right? But what I always tell my students, and of course I'm a little bit biased, but keeping mathematics up really keeps your options open. And if you can keep that up for as long as possible, you will find your options will stay open for the longest time, just because mathematics is so foundational and so jolly useful. When I talk about mathematical science, I mean statistics and sort of aspects of data science as well. So mathematics manifests itself, and the skills that that people need in mathematical are just such a broad spectrum. So for me, it was always the foundation for which I could sort of come back to while still exploring some of my passions, because I would really counsel young students to, insofar as you can, follow what brings you joy, and having mathematics in the background will actually give you that backup, that solid foundation, that if you do need to pull back, find, look at some more vocational options beyond just following your passion, then that's always a good backup.
Yeah, so the question related to at what age do you try to make up your mind to choose a career? So this is very, very difficult because we know today that most of the IITians who are supposed to get thoroughly trained in engineering land up doing some finance, marketing, and so on and so forth. What career do you choose is something which people try to make up their mind in some form or other, but it keeps changing. But one thing is true, that as Clemency was mentioning, so whatever is giving you joy, you should do. At some point of time in my life, the Sanskrit and the Shastras was so fascinating, particularly during my elementary school days, I would say. Okay, so elementary means so something like between the age of 10 to 15. So I was so passionate when I listened to some of these people speaking in Sanskrit and then beautifully exchanging the ideas, fighting with each other in seminar. So I was just wondering, why should I not become one of this group? So in engaging, because I felt like there are very few people who can do this dialogues in Nyaya Shastra, Vyakarana Shastra, and so on and so forth. But somehow my father said, so it is okay. So you can learn that later. So you better do this science. So anyway, I can teach you a little later. So this is what he said, and he encouraged me. Okay, I did not so want to disobey. So those were days where we were little obeying what our parents said. So then I decided to continue my own career in school and then into college. Okay. But I must tell you that I had absolutely no clue regarding career, but I was just enjoying what I was learning, whether it is Veda, whether it is Sanskrit, so whether it is Hindi, whether it is some other thing. So at whatever level it was given to us, see, it depends on where you are put in. That is why. So if you have a fantastic teacher to motivate you, then I think your brain literally starts flowering. So that is why it is extremely important. See, I am so happy that Vinay, Hari, etc. So they are trying to support students who do not get that kind of a support system to make their brains flower. So it is important that even if you listen to a few hours of lecture by someone who can thrill you, okay, so there is nothing like that. Your career gets shaped. So that is why it is extremely important. And depending upon, see, now there is a certain trend that people try to choose those career which can be highly lucrative rather than whether it is really enjoyable in the long run or not. This kind of a thought doesn't come. But I must tell you, since most of you are young students who are here, you should not just simply get carried away by those careers which you feel is going to be highly lucrative. No. Okay. So these lucrative jobs, etc., can be fascinating only for a very short while. Okay. Believe me. So this is, but when you try to engage your minds in doing serious academics, it can keep your interest till the end of your life. So it is extremely important that you train yourself to learn new things and enjoy in that process. See, so that is the process which can keep your mind agile also. See, otherwise what happens is in a few years, I have seen several professionals at the age of 40, 45, I mean, they get aged. And so unfortunately, they are not able to pitch into other disciplines. So therefore, it is important for you to try to your build career in doing serious academics. Okay, particularly in pure sciences, and mathematics can be quite thrilling. And let us come to this history of mathematics part. Okay, so this is where myself and Clemency have been working together, and it was again a providence that I met Clemency almost 10 years back, somewhere in ICM, in 2010. So we just had been there to Kerala for a satellite meeting, and that was the first meeting point. And then, I mean, we have worked together also, which has been far more productive. I think I'll stop here. So we may not be able to say that at this stage. So I'm not saying that one should not plan for a career. So one should pursue interest. But when you pursue interest, so you just do that thing. Okay. So putting all your mind into it, whether you are sweeping or you are learning an important mathematical problem, doesn't matter. Do that. So don't worry about where this is going to lead me. So at that moment, I should just see that I engage myself fully. This is very important.
And I just want to pick up on that lovely, very important point about keeping your brain thrilled. And, when we have the pleasure to work together, Professor Ram, often we say, every day we need to learn something new. And so quite often we'll spend the day, as well as covering the things that need to be done in the process of collaborating together. Sometimes we'll sit there and we'll come across something, and maybe it's not until late in the evening that we do, but that's the challenge for ourselves, to keep our brains thrilled. And we're just really privileged to have that opportunity to do so, even after, years and years of working in this field. So keep your brain thrilled. That's the question you should be asking yourself. How can I keep my brain thrilled?
Yeah. Thrilled is one thing, and challenged is more important. So Clemency invited me once to New Zealand. So we were breaking our heads for almost 4 days on one single verse. It was not a thrill, it was a challenge. But then comes the thrill at the end.
So was that a disagreement on that verse, or what was the challenge actually?
Yeah, disagreement is one aspect. Sometimes we do disagree. But
that can be very fruitful, right? I think our disagreement is generally with an ancient author who is not being particularly open about explaining why a particular, rule or mathematical theorem is actually true or not. And we're,
So that is one aspect. So that the other thing is this verses do not necessarily have a commentary. So fortunately, certain texts that we have been studying do have commentaries. Certain texts do not have commentaries. So there you don't have a clue whatsoever. The other problem is when a manuscript gets written by somebody, so it becomes exceedingly difficult for you to even decipher the handwriting. So sometimes you will miss some dot somewhere, some visarga somewhere, some full stop somewhere. So then you are finished. Okay, forget about having equations, having diagrams, nicely explaining the concept, etc. So that is something which is different. So you have a certain tradition where you have to pack things. So mostly people have been orally transmitting the knowledge, and therefore you keep something very, very minimal in terms of retaining in your memory, whereas it will be explained by the teacher to the taught. So this is how the tradition has been. So keeping up the tradition, I mean, even in later times, people have been simply, and see, you should also remember that we didn't have the luxury of having nice papers as much as you want, etc. Today, I mean, I can just complete one bundle. So if I go to Clemency's office, she will say, just go, let us print out. So whatever we want, we can just print out, whether it is 500 pages. And we have a very powerful machine which will just throw the printout 60 prints per minute. So these are things which we have. But in those days, so people had to either write in palm leaf or write in some paper or write in some cloth. So they will try to minimize the resources, and it was a compulsion on their part that they could not afford to. So therefore, people have been squeezing things. Okay, just try to put. So all these things actually throw some challenge. Okay? So decipher something from the manuscript, and you have to sort of collate. So then, of course, the ideas themselves could be somewhat little new to us. So it is a little different line of thinking. So we are trained in thinking in a particular way. So she said, starting from Euclid, I mean, there is a certain tradition. But this kind of a tradition may not be starting with propositions and then building upon that. So this is a different kind of a tradition. So we have to just enter into their minds. So that is the kind of challenge.
So just for the sake of the benefit of our audiences, just that the style of writing ancient mathematical texts in India was that it was written in the form of verses. And it's always a challenge to explain something mathematically in the form of verses. That's where it gets hard to decipher sometimes what the author of the text is trying to say. And I really liked a point that Professor Ram said, and that is about when you're doing something treat it as an end in itself rather than a means to achieve an end. A lot of people, they go for a career from a perspective of they select a course from the perspective of getting a job. So the education becomes a means. The end is not the education itself. But if you are doing a particular course and you put that as an end in itself, I think that's when you can excel in that field. And also another point that you mentioned was really important. That is the importance of getting good teachers. And I cannot tell you how lucky Vinay and I were when we were able to attend a course that was done by Professor Sri Ram, and Professor MD Srinivas at IIT Chennai in 2014. That was a course on, it was just a beautiful compilation of the entire history of mathematics, right from the Vedic era to the modern era. And it was structured in such a beautiful way. It's a 40 lecture series, and I would encourage each and every one of you to go to NPTEL, which is an online platform launched by IIT and IISc. And I would encourage you all to search for the lectures on ancient Indian mathematics by these three professors. They are fascinating, to say the least. And that's how Vinay and I got interested, and we thought that this is something that we should communicate to school students, and that's how this happened. So I highly encourage you all to do that. Moving on, so can you both tell us more about what does mathematics and humanities entail? Like what are the areas that are covered? We know that history of mathematics is one area. Are there other areas as well that get covered in this field?
So I can start perhaps. So when you combine mathematics or and physics and related subjects, statistics, data science, with a humanities subject, be it history or something other in social sciences, sociology, anthropology, what you find is that there's a huge range of more career-focused or ways in which you can have an impact in society. And quite often they'll be put under the umbrella of digital humanities, which looks at the ways in which digital technologies have relationships to culture. So for instance, people who are examining social media or the influence of big data on our decision makings, digitization of text, digital archives, which are becoming all the more important. Things like data visualization rely both on a very humanities bent to understand the information that's coming through, as well as the mathematical backdrop that's used to actually make sure this information is correct and put in properly. Things like textual mining for services to get trends, to look at political trends, social trends, global trends. And on the flip side, for the good, and for when we look at, particularly in recent times, the spread of disinformation on social media. So both of these, to really do these seriously in a sort of a digital humanities lens, requires both a humanities subject as well as the technical wherewithal to be able to tackle these with real, genuine, authenticness. So this is a very important and rapidly developing area where you can very meaningfully make a contribution to society by combining maths with a historical topic.
Yeah, see, humanities, one aspect of humanities is history. There are various other aspects of humanities that you can think of. So you can think of philosophy, you can think of literature, so you can think of poetry, you can think of art, you can think of performing arts. So all of them fall under the big umbrella called humanities. So particularly when you take the poetry aspect or art aspect or performing arts aspect of it, there is a beautiful connection that you will be able to see between mathematics and how it has been integrated with the art. So all that we need to know is there is a certain link and a serious link between performing arts and this mathematics. In fact, one person went to the extent of saying So while introducing mathematics, and in fact, you will find this reverberating in almost every textbook on mathematics today. So in Sanskrit, almost 10 centuries back, okay, 10, 11 centuries back, so a person, so when he wanted to motivate the students to learn mathematics, so he just said, Yet kinchid vastu tatsarvam ganitena vina nahi. See, so what does it mean? See, so he says, you tell me anything in the world, I will tell you how mathematics is connected with it. Okay, so you cannot isolate yourself from mathematics. Those students want to. Okay, so but what is mathematics is something which we need to appreciate from a larger perspective. It is not just solving. Okay, so this differential equation. Okay, so it is not just solving some group theory problem. It is not solving algebraic geometry some problem and so on. But mathematics starts with addition, multiplication, division, and if you just analyze, you cannot think of passing a single day without doing some sort of mathematics, which basically is counting and computing. So Ganitam essentially means counting, computing, calculating. Can you ever spend a day without this? Forget about your birthday, so whether it is festival, so everything requires counting. So let us understand that. Whether it is having investment somewhere, so and thinking of interest, etc., which has been there forever. Okay, so all that. So if I invest this much of time in this, so then what is my gain, etc. So everywhere this thought comes, and it can be put in various forms. Okay, so therefore, so humanities, when you say particularly, I just want to highlight one thing to students. See, when you think of mathematics, so in fact, Hari alluded to the fact that mathematics is composed in the form of verses. So when you say verses, so you have to understand that there is a certain metrical pattern associated with that. So studying patterns is something which is very much a part of humanities. Whether you do it as a combinatorics or you get introduced to it through permutations or not, so it is, that is what it is. You have to understand. So this has been analyzed in some of these texts in those days. So when I say those days, texts which have been composed almost 2000 years back. So whether it is Natya Shastra or Chanda Shastra, you find sections devoted to this study of patterns. So the studying pattern, I mean, is something which we do even today. In fact, Google, all that it does is recognize some pattern of the face, and you type Clemency, her face will come. Okay. So this is what they are so trying to do at some level. Okay. So this is what they are trying to do. So this recognizing pattern, and so what has been done here is, even if you think of, so let us say percussion instrument, all that you do is some sort of a beating. So within a given time, so how much of beats that you can generate, and what kind of patterns that you can generate. So depending upon the speed with which you do, depending upon the mixture that you do of your hits, I mean, it gives you a different kind of a feeling. So therefore, mathematics cannot be disintegrated with humanities. So that is all I wanted to tell you.
Fabulous, fabulous. But it's reassuring to hear that 10 centuries back also teachers had to motivate their students to learn mathematics. So it's not that something that has happened in the recent past. So that's reassuring. Okay, I think one last question, and then we will go to the Q&A from the participants. Uh, what are some of the universities which you can target if you want to combine mathematics and like liberal arts? So Clemency, you can talk about universities outside India. Maybe sir can talk about universities in India.
Do you want to go first, Ram, to talk about universities in India? Better to start local.
Okay. Right? Yeah. See, the problem today is, if you take the list of universities which are offering courses on history of science per se, you will only get a null set in India. Okay, history of science. So be careful when I use the word. So there is one small setup in IIT Bombay, which got sort of established almost 20 years ago. So where the idea was to primarily look at scientific texts in Sanskrit. So what I was mentioning earlier was history of science per se. So it is not something which has been considered as a very serious discipline, unfortunately, though you will find hundreds of history departments. Those history departments, what they primarily do is to just study, analyze this medieval India, what is Sati, what is this, what is that, etc., etc. Okay, and primarily try to provide a certain image in your mind that you don't have any affinity towards India at all. So that is the kind of history which is being taught here. Okay, so how Aurangzeb was great, how Akbar was great, and so on. So this is what is primarily sort of taught. So it is a banal history. That is all I will just say. Okay, so a banal history which is not going to be highly productive is what is being done. It is sort of unfortunate, I must tell. I mean, I'm not trying to say that all, by and large, that is what is the trend. So there are serious historians, and I also know of episodes where certain history which is being really brought out by serious historians will be subverted. Okay, so for some reason or some other reason, I mean, they will try to suppress and that will not be published. There are various things which are happening at a political level. Okay, so this is one aspect. But the other aspect is, so for anybody to choose a career to get into this, so as Hari or Vinay are concerned, so that is why they asked this question. So one should see that there is an avenue for me when I do this, for me to get placed somewhere. Obviously, one needs some support, right? So there has to be respect in society. There has to be a way of living. So both these are essential. Some minimal things are required. So therefore, people have not been engaging, okay, very seriously, unless people have been passionate by themselves. So you may be a mathematician, so where you need not get into history, but there have been people who have got into this history. So it is purely out of their own passion towards that field. So he may be a lecturer somewhere in some college. So there is one person called R.C. Gupta, I must tell you. So he has been carrying it out with great passion. So he was some professor somewhere in some college, okay, not even very well established university. But he had developed a passion and he has written hundreds of articles, okay. And he was also awarded the Kenneth Tome Prize. See, so there was an international recognition which happened. So when he is almost 80, that is okay. So one doesn't do that for any recognition. One does it out of passion. So the avenues in universities, I would say, are very little even today. Okay. So fortunately, this unit was established in IIT Bombay, and a few bright students came, and I was lucky so to sort of guide them through, and they have also got placed. So currently, if you want to say, so there is one unit. So there is one of my students is in ISER Pune. There is another student, I mean, who is in IIT Madras now. So there are, and there is one place in IIT Gandhinagar, so which is trying to promote this. There is one called Professor Michel Danino. So he has been trying to push this Indian knowledge systems in general. Okay? And barring a few places where there are a few faculty members, so primarily this discipline in India got developed out of the passion of either somebody doing mathematics or somebody doing astronomy or somebody doing theoretical physics and so on and so forth. This is how it has been. The scenario has not improved much even in recent times. So there is a hope that this National Education Policy 2020 so has a much broader mandate and there is a possibility that this can build over the next few years.
So I'll follow that up by saying one has to be very careful too when we talk about history of mathematics, because what you'll often get, of course, as Professor Ram pointed out, is Newton, Leibniz, Darwin, all the great Western names who have contributed. That forms the basis, very sort of ethnocentric accounts of what knowledge cultures have been over history, with quite a narrow but important strand of thinkers throughout history. It's much more difficult to get a broader approach to how humans have embraced mathematical ideas and carried out mathematical ideas from a real variety of cultures of inquiry throughout history. And so really important, I think, the plug is, it's a source of national importance that we understand who our scientific predecessors are. Particularly for you in India, there's Aryabhatta, Brahmagupta, Bhaskaracharya, all of these incredibly great, gifted geniuses throughout history. This is your legacy. This is your scientific legacy. This is the scientific legacy of, a fifth of the world's population. It's really important that this stuff is well preserved, well understood, and well promoted as a source of looking back and seeing the roots of our foundations of your intellectual culture. So I would encourage you, when thinking about the history of mathematics, actually to push a bit further to look at what are some alternative or what are some different traditions of mathematics that are equally as important as some of the mainstream ones that typically will get taught under the form of history of science. So, for instance, what are the traditions in India? What are the traditions in New Zealand, the Maori, indigenous populations? Because as a mathematician, we're really interested in the different ways in which we might think about similar ideas, the different structures we might approach things. And what you'll find if you look historically is that very bright, intelligent individuals who are working in contrasting intellectual circumstances all come at the ideas of mathematics, such as symmetry, such as patterns, such as shape, form, number. And because they are working in different intellectual conditions, they come up with some really insightful different ways to conceptualize these objects in ways that are incredibly fruitful for us as thinking human beings to think about these things. So beyond just, the general typical narratives of history of mathematics, I'd encourage you to make sure that when you're, if you're really keen on pursuing this, that you look for programs that will really give you that cultural breadth, because we're talking about a global endeavor here that was pursued by every single society that we have seen, including ours today. So I would say, again, just like in India, less than there are actual places which are quite famous, there are particularly faculty members who happen to be at particular places which are good to follow. So Brown University has got some really interesting things going within history of science. Union College, Stanford for the more Mediterranean traditions, for instance. Trinity Western, NYU, which does very ancient stuff. So there are lots of different places, but again, they're pockets, and they're generally tagged to a faculty member who has this particular research interest. Rather than, or you can come, of course, to the University of Canterbury in New Zealand when we open up again.
See, Clemency went from this side of the earth to the other side of the earth, okay, north to south, and of course leaving almost 180 degrees in between. Of course, India is known. So I must also add that we had occasions to meet in Paris. So there is a small group which is working in the University of Paris, which is interested in the history of mathematics. And of course, Chinese have, but primarily they study Chinese mathematics. Okay, and there is also a small group in Japan. So currently, it is not something which is very strong, but it had been strong for the past 20, 30 years. So I must tell you, from 72 till 2000, 2010, so there were a few people who took very seriously the study on history of mathematics in India, and to some extent astronomy also. So currently, I don't know whether there is anyone, who is young to take it forward, but definitely there were few. So of course, New Zealand. So I can add that see, so besides the beauty of the place, so the beauty of the faculty also. So who has a really beautiful heart to really encourage students to pursue the study. So I must say that if you get an opportunity, whether to do a doctorate or a postdoctoral, so you should definitely explore University of Canterbury.
Namaste.
Fantastic, fantastic. With that, I think we can open the floor to participants for questions. So if you have questions, just raise your hand or ask your question in the chat. So Vidya Sriram, can you ask your question? Please unmute yourself and ask your question.
Uh, Namaste to everyone. It is very interesting thoughts that hear from Ramasubramanian ji and Clemency. Thanks a lot for that. So I was just spending some months now to read about the history of Indian mathematics, especially the course on NPTL. And with that, I was also studying about Hindu calendar and what is the scientific significance and the reasoning behind it. And I was really surprised to see a very elaborate paper about Hindu calendar, different regional calendars and its scientific significance, done by some students in National University of Singapore. Under some professors' guidance, there are a couple of students in different aspects of the Hindu calendar. But I'm not sure if I did not come across any of the Indian university papers, but I couldn't even locate a single research work on Hindu calendar and how the mathematics and science played a role in calculating the calendar per se. So I was just thought of getting some inputs and thoughts about this on why Indian students are not exposed or even encouraged to do research work on such topics, which really are insightful.
See, Vidya, so the concern that you express is something which many Indians do have. Why they are not doing is simple, because they are not encouraged to do. Why they are not encouraged? Because faculty themselves are not aware of it. Okay, so this is simple answer. But the other thing is, it's not that this National University of Singapore or somebody studying there doing work on this calendrical system. If at all they had done, I can bet without even seeing the work that they have just drawn inspiration based on some of the works which have been done by. So you may not have access to those works. So for instance, there are some brilliant publications which have been brought out by Indian National Science Academy, wherein you will find plenty of discussions. Okay, history of astronomy in India. So it's a book which was brought out 3 decades ago, which has several articles which bring out the distinction of various calendrical system, and it also builds, okay, so the narrative as to how people have been doing computations, etc. This is one book which I can recommend, which does not have a lot of Sanskrit. So there are original source works, their translations, interpretations, and so on. But as a person who is interested in knowing some things, so history of astronomy in India, so this is an edited volume. It contains about a dozen articles. So some of them are very general in nature. Some of them can even give you some particulars. Okay, so this is one book which I can recommend you to read. Of course, the calendrical system is not a simple thing. It is quite a complicated thing. So in fact, a couple of students of mine will be taking it up very seriously, and how it can be improved upon along the same lines. So there are very, very interesting problems which can be attempted in that.
Lakshmi, can you unmute yourself and ask your question?
Sir, can I ask? Now I've been unmuted.
Yes, yes,
Sridevi
yes.
here.
Yes, yes, please go
Sir,
ahead.
this is a question regarding, before that, thanks for the wonderful discussion for both the great personalities. Coming to the question, Ram sir was telling about encouragement by good teachers. Yes, I do agree to a great extent. But I think there should be encouragement from parents as well. Because most of the parents today tell either join engineering or medicine. It's the most of a status question that I have seen being a teacher myself for the past 20 years. And that is one thing. And how should I, being a teacher or a teacher trainer, how should I pull the parents out of this loop? It is very difficult for me in particular to pull the parents out, stating because they keep on forcing their children to join engineering or medicine or taking up IITs exams and all that stuff. Yes, fine. But though the child doesn't have the caliber, still the parents keep on pushing all their ambitions on the children, which I feel really bad for the child because he's neither here nor there. He's in a soup. That was one question. And the second one was he was telling more about history and liberal arts. Yes, today's education system doesn't focus on that. I really agree. And I think Ram sir also agrees to that. But how can we build this being teachers in the school within the set period time?
So your concern is genuine that there are two different directions in which the children are taken. So they may have some interest in something, whereas their parents try to impose that they have to do this medicine, they have to do this professional career, so that they can earn better and so on. So this trend is not something which is really as bad as it was a few years ago. So that is one thing which you have to understand. But as teacher, as a school teacher, all that I would suggest to you is we can make an impact irrespective of what is happening based on the instructions that they receive from their parents. Okay, so this I can tell you for sure. So as teachers, we can really contribute in shaping their minds because they are there with us, with every teacher I'm telling you, for a few hours in a week. So if we can really make them appreciate the subject matter which they are learning by providing historical inputs as to how the ideas emerged, that will shape their minds. So forget about what is being said, what is career, etc., etc. I think as teachers, we have to really worry what kind of quality that I am able to build in my own course, and what can I do to effectively communicate this to the student, going out of the syllabus, make them interested in doing certain things. So this is what I can do because our hands are tied. You cannot even open your mouth. Okay, so in the class there are various restrictions which are being imposed by the management. So otherwise, so there are various other problems that we have. So and much less can be done regarding the parents. So this is something which we need to understand for things to change. So the overall perspective regarding education has to change. So this is what I earlier also mentioned. So it is not merely the earning. So there was a serious problem in those days. Why this trend got set? Why should you go to engineering, etc., etc.? People have been facing a lot of poverty in various places, and therefore they felt that this is the most important thing. But today that is not the scenario. People are really craving, I must tell you, for a much broader kind of education which can be made available because people have improved. Okay, the affluence in the society has increased in a certain section. Okay, we may not be able to say that this is true of every section of the society.
Thank you. Lakshmiji, can you unmute yourself and ask your question?
My question is twofold. One is in the past and the other one is in the present. In the past, as a student who is currently pursuing research in ancient Indian mathematical texts, I have come across a lot of material which is sometimes very biased in trying to establish racial superiority, or rather, racial inferiority towards what has been already available in the past centuries. So, is there a possibility of a course correction out here, like trying to come up with a middle line, which is especially talking about the truth of it, rather than looking at establishing the superiority or inferiority, or how how we got to know this kind of knowledge, whether it passed from the Greeks, or we got it from the Greeks, or the Greeks got from us, and that kind of this thing. So a lot of mudslinging is happening out there in terms of establishing the truth. In what exactly the history is when it comes to particularly mathematics, because mathematics happens to be the most foundational of all subjects. So how are we going to even establish that kind of a truth in this particular area? The other question is for the present. As a teacher myself, I somehow find that when it comes to mathematics, especially, the current way of teaching mathematics is more about lot of abstract ideas, rather than bringing an application oriented approach to mathematics and make mathematics be felt as a very practical subject. There is a constant effort to make mathematics be felt as a subject that must be feared. Algebra, you have geometry. So some few months ago, I had the I was fortunate enough to listen to a talk by Vinayji, where he stressed upon the decompartmentalization of topics in mathematics, which is a very valid one. So how are we even going to do that? Because from the text that we see here, though they were actually compartmentalized there based on specific topics, there was an application view about what was done. The examples that were given there were so practical oriented that it is very easy for anybody to relate to that, even when they took a brief look at it. But then if you look into the current textbooks, the syllabus that is given to us as teachers, I find it highly demotivating. I'm not able to take it to the children. Children are just going to lap up what is given to them. So how are we going to even motivate the children when we teachers ourselves are not motivated? Thank you.
Clemency, want to start?
Yes. Yeah, I'll pick up on that last point. I thoroughly agree that there's huge power and potential of teaching mathematical concepts in context or in perspective. Many people complain about, children are unable to grasp trigonometry, for instance. And I think if you actually teach it with its roots in early Indian tradition, for instance, at the moment we teach it as ratios, right? Sohcahtoa, right? But to me, looking at it the way in which really early Indian mathematicians, Brahmagupta, Bhaskara, looked at it as given a chord or given an arc, what is the corresponding line segment is very natural and visual. And so approaching these topics, when you're looking them at in context and looking what motivated the original discovery, it can be incredibly powerful to the sorts of learners who are not immediately attracted, as you say, to the more analytical, algorithmic approaches. Here's a method, off you go and do it. So there's huge power and potential, I agree, to put mathematics in context. And some efforts are being made with particular topics in undergraduate curriculums and high school topics to be able to provide modules for teachers to actually present some of these ideas with their historical roots as another way for getting students deep comprehension of these mathematical ideas.
Yeah. So Lakshmi, so I completely agree with you regarding the problems that you were trying to point out. So there is a certain effort which is being made across the world to make mathematics more interesting. One more effort which has to be made, particularly in India, is to reduce the content, make it more interesting. So there is a lot of material which is being thrusted, so which may not be fully digested by people. So this is a different kind of a problem. So there are efforts which are being made, and what is to be done to change this? So some of us have to first of all educate ourselves about this. So as Clemency was pointing out, so trigonometry teaching with this, first of all, do you know that there is such a tradition? So you have completely lost. So therefore, some research, in fact, the last few days, I must tell you, I was engaging with a couple of my students who were studying a certain text called Aryabhatiya with its commentary by Nilakantha. So I was quite thrilled to know the kind of practical dissectional methods which he recommends in order to understand a given algebraic expression. So Lakshmi was mentioning that people have some phobia towards algebra, etc. So that may be true, but the point is, if you can connect this by some other way, so then there is a much easier way by which this can sink into their minds and they can appreciate the beauty of how two different things are connected. So doing something in algebraic fashion merely as a square b, ab square, etc., is one thing. But as children, I mean, if you can show that this block basically corresponds to this, they can play around with that, and then they can very easily see that these two are one and the same. So what we can see as a block can be also represented in the form of some algebra. So this is the kind of connection that we need to bridge. So what we see as a ratio is nothing but, so this chord and this thing, and why is it important, and so on and so forth. So therefore, effort should be to first see what is there. So because many things are not even known to us. So once you know that this is a different line of thinking which people have pursued, then you can bring it. So this is one aspect. The other aspect, the first question is, so I don't think we need to really bother too much now. So what Lakshmi was saying is, so there has been a certain agenda which people have been holding to. I'm not trying to deny, okay, because I know I have studied certain things more deeply. So this kind of bias in presenting the history, this has been there, and I don't think we need to really bother too much. So if we can create a critical mass which starts studying, then the narrative will start changing slowly. So this much I can tell you. So see, we were under certain rule, and nothing much could be done, and it is only these people who have been writing in those days, particularly in English. So we had a certain passion for English, and everybody today, even if you go to village, so he wants his son to call daddy rather than papa. Okay, so that is what is happening. So, and therefore, if you are mindless and so crazy about this language, which we have been doing, so that is what I think we will learn. But slowly, I think this narrative will change. So, provided more people take it, and today we have various ways of communicating also. So, in those days, this was not available. Think of this platform which Vinay and Hari have created. So this is something which we can do today. So irrespective of what is being taught, what is being prescribed in the curriculum. So that is one aspect, but there are other ways of educating people, and educating people, I think, is the concern which Lakshmi had, and we can do that. I think in next couple of decades, I think it is quite possible. So some of the teachers like you who have taken interest, so have to also think of formulating syllabus, text, integrating something along with what you can do. Okay, so there may be some difficulties the management may pose. Why are you teaching this, etc., etc.? But in spite of this, I think you can do.
Thank you so much. I think that's a very important point we should take home, and that is, in some sense, when we talk about research in mathematics, how do we start? We start with going back to some of the earlier papers and what work has already been done, and we start from there. And I think in some sense, history plays that kind of a role when we look at Brahmagupta's texts and we try to understand how that tradition of for example, quadratic indeterminate equations came about and how that was eventually solved in that tradition. Okay, Vagisan, can you unmute yourself?
Yes. So, like, I'm 11 years old, and like, in what career like should I choose? Like, because like I'm, I'm like interested and I'm passionate about mathematics, computer science, linguistics, and music. So, like, how how can I like also integrate these and like try to create some teaching material, or like try to do some teaching to other people, and like how is it possible to like study like uh, ancient texts, because I have like I because I'm fluent in English and Tamil, and know Hindi and Chinese to some extent, and French and Spanish to a little extent, and some amount of Sanskrit. So is this enough to like understand the ancient text?
Yeah. So Vagisan, I am happy to know that you have got exposure to several languages. Okay. Getting exposure to a language is one aspect. So gaining mastery in the language is a completely different story. So if you want to really do some research, so then I think you should try to gain mastery. So you should just see to it that you try to master the language. So language is obviously a medium, but what we use to express our thoughts either in mathematics or in astronomy through a language is by building a certain technical vocabulary. So merely knowing language does not help you in understanding these texts, but language is a must. So it is very, very important that you pursue a particular language. See, gaining mastery in every language may not be currently possible, but I am very happy that you have exposed yourself to Chinese, Spanish, this, that, etc. That is fine. But if you want to do research, then I think you should gain firm footing. If you want to pursue research in Indian science and technology, Indian mathematics, astronomy, etc., so then you have to put much, much, much more effort in gaining mastery over Sanskrit language. Okay, so this is a must for you. So there is no other option, because this is the language in which most of the texts have been composed. So it's not that other languages do not have text, but the richness of literature that you find is only in Sanskrit. So therefore, try to build. So this is the age, you are just 10, 11 years of old. So up to 20, I think you can very easily pick up things very fast. But after that, the curve will go down. Okay. So Vinay Nair, suppose he decides that I am going to become a master in Vyakarana Shastra. So it may be an impossible task. And for me, it is absolutely impossible. Okay. I am much older than him. So this picking up skills in language can be very easily developed when you are in teenagers. So first of all, I'm happy that your parents took efforts to expose you to several languages. So that is very interesting. Okay. So in no time you can pick up. The mind is so fertile. Okay. So just gain mastery. That is very important. Now don't worry about trying to integrate various fields. Okay. So you don't need to worry about it. You will do even if you do not want to. So this is what you have to understand. So our idea should be to gain foundations, okay, in different disciplines. So how you can connect, etc., that anyway mind will do, even if you do not want it to do. So that you will do later. So right now, so if you learn mathematics, try to learn well. If you learn Sanskrit, you try to learn well. So then this integration will naturally happen. So when you come to a stage where you start thinking along those lines. Okay, so that is where, I mean, so you don't do a doctorate when you are 11 years old. So only when you are 21, I mean, you will start doing that. Okay, so therefore you need not worry about that. So you have to just store in the right information. So don't engage in reading novels too much. So you better learn other things. So this you will be able to connect. Okay, if Clemency has to add something.
I think because I thoroughly concur. I know we're short on time, so I won't add to that.
Thank you. Thank you. Muthulakshmi, can you unmute yourself? And I hope
part of the question was answered in the previous answer. Uh, the only part of the question that I want to ask is, because Sanskrit plays such an important role in the Indian context to understand and bridge with our historical knowledge, the emphasis of Sanskrit education in school level is being so low. What can be done to ensure that we spread the knowledge of Sanskrit to all the young students?
Muthulakshmi, so your concern is understandable, but today you cannot have the excuse of saying the school doesn't offer and therefore it is difficult for me, because there are hundreds of other agencies who have been very seriously promoting Sanskrit studies. And thanks to this online platform, so which has really enabled hundreds and thousands of people to learn. And thanks to COVID too, so which made some people to sit at home and start learning more. Okay, so this platform is available today. So there are various platforms which have been developed by individuals, by institutions. So Sanskrita Bharati has been doing, Rashtriya Sanskrit Sansthan has been doing, and Vyoma Labs in Bangalore has been doing. So Clemency also has. So there are several platforms which are available. So the only decision that you have to make is, so you will try to make your children engage in learning this language. I must tell you at this juncture, because I'm reminded of that. So when I was 10-12 years of age, so my mother compelled me to take a few exams. Okay, so no option. So Bharati Vidya Bhavan, so I had a series of exams. So every 6 months you have to take, no option. So similarly, Hindi Prachar Sabha was there. So every 6 months you have to take exam. So once you do this, so as mothers, I think in India you can do this, maybe not abroad. So if you can compel your children to take some of these exams, take these courses, if you can manage to do that, then I think you will be doing an immense service to your children. Okay, so let me tell you. So now I realize, so in those days, maybe I would have cursed my mother that she did not allow me to play. But now I realize the importance of it.
Clemency, you want to add something to that?
I guess just a pitch for Sanskrit, you know, with student uptake as having inspirational and amazing teachers, and sometimes you may not find that directly in front of you face to face at your school environment, but just search further afield. You know, there are many opportunities, spoken Sanskrit, you know, lots of online courses or something outside of school. For the same reasons that I started with Latin, it was not just to read ancient texts, but just for the beauty of the language, the understanding of how language works in general, linguistics, you know, the way in which we communicate, the mechanisms in which human phonology actually works. So it's not just a matter of reading Sanskrit for a language, but actually it's an intellectual study in and of itself for understanding so much about what is fundamental to us as humans, that is the ability to communicate. So I'd really encourage
Yeah. See, I must add one more thing to what Clemency said. See, we do some history of mathematics, astronomy together, but we also do study some Kalidasa's work. So Meghaduta, Raghuvamsha, etc. When Clemency drives me from her home to some resort, so those 2 hours, so we spend learning a few verses. So I will keep chanting, she will keep repeating. And by the time we reach there, she would have memorized these verses also.
Yeah. But I'm
Okay.
mostly concentrating on the driving. Don't worry.
So as Hari was saying, she is polymath, so she can do multiple things also together perhaps. Because I am sure, okay, that she will drive safely, but that is why I engage her to also simultaneously learn myself. No, no, the point I wanted to convey was science and mathematics is just one small aspect of this language. The beauty of the literature that has been created in it is something which one cannot afford to miss. So take it Kalidasa, take it the analysis of the linguistics, take it the analysis of the phonetics. So the analysis of the literature itself, how can you classify kavyas, and how can you find different kind of layers of meanings, how they are embedded, and theorizing all of them. See, so this is what is something which many of us do not literally know, absolutely no clue. I'm telling you. Okay, so a few days back I was just teaching one Japanese student, so who wanted to have some exposure to study this Kavya Prakasha of Mamata, which was composed in 11th century. So when I read, the kind of thrill that I had in trying to appreciate that was really phenomenal. So this is something which one cannot afford to miss in life, whether you are an engineer or you are a finance manager or you are a banker, so or you are a political analyst, doesn't matter. So you have to spend some time enjoying the literature.
Great, great. On that note, I think we can end the session. So I would like to request Vinay Nair to give a vote of thanks to our speakers.
Thank you, Hari, and thank you so much, Professor Clemency and Professor Ram, for joining us. In fact, you shared so many things, and I think this itself could have been could have been a half day or a full day session where we could have interacted so much. And the audience also, you asked wonderful questions, and I think that was quite relevant to most of you. And one thing that I just wanted to share is, like how Ram sir was pulled into this particular area when somebody motivated. Like Hari said, Hari and I, we were pulled into this because of Ram sir and his colleagues. So initially when we get into this history of math, it can be a little intimidating. My first experience when I met Ramasubramanian sir in Rashtriya Samskrita Vidyapith in Tirupati was accidental, because I thought it is some other conference, and I went there and everything was going bonkers for me. And it was, but I found it a little interesting. This is something very interesting. So I even remember going to his room in the evening asking for some lame doubt. But he was very encouraging, and since then, I caught on to his tail, and then he has been quite quite supportive in sharing whenever possible, wherever there are programs. So that's when I came to know that there are so many places like IIT Madras, IIT Bombay, now IIT Gandhinagar, where they offer so many courses on history of mathematics, especially Indian mathematics. And in many of the cases, they even support you monetarily to come and go in case you are not able to meet those kind of things. But there is no one place where we can get about all these information. So I would suggest try to be in that circle, be connected with people, and that's how you can get to know more about it. And lastly, it's very hard to get time of people like Clemency and Professor Ram, and I've seen them closely working, how how busy they are. But they readily agreed when we told them that it's for the sake of students and who would like to know what kind of opportunities lie in humanities and mathematics, and they readily agreed. And they are there few of such historians who are truly passionate about education. I think that's what brings them here, and you can see how they can talk in terms of the layman's language. So we are extremely happy and thankful to both of you for taking out your time and sharing your valuable insights with all of us. And I really appreciate and thank the audience for such a for such being a wonderful audience and asking great questions. if there are any questions that you had and you couldn't ask or we couldn't take your question, our apologies for that. You can write to us at Raising a Mathematician. You can see the name on my backdrop, Raising a Mathematician at gmail.com, and we'll try to get them answered. Okay. So with that, thank you one and all. Thank you once again.
Vinay,
Yes,
see, it
Ram
may be
sir.
more easy to find people like us, but hard to find people like you. So, who have committed themselves to raise a mathematician. Okay. So, I am so happy that you are doing a fantastic job of trying to motivate the young children to understand mathematics thoroughly and thereby make them enjoy mathematics. See, so that is very important. One small thing, since you were mentioning about humanities and mathematics, even from the viewpoint of studying what are called columns. See, the column is something which you find almost in every household. So there are some beautiful patterns. So I think one can analyze. So all that music, column, any kind of performing arts. So we should just tell them that they are connected. So they may not be able to appreciate at the age of 3 or at the age of 13, but they can definitely appreciate it once they grow. But you should just tell them that these are some mathematical aspects. So thank you very much from our side as well. Okay. So
Thank you.
Clement,
Thank you so much.
Thank you.
it is always a pleasure to share the platform with Clemency.
Oh. And I'm looking forward to when things cool down a little bit and I can come to India again.
Yeah. So mutual exchange program.
Looking forward. Thank you. Namaste.